All right, so from the DSAT shell, I'm going to go to, I'm going to open Xbuild by clicking on the crop management data tool over in the left-hand tool menu. And that opens this new application, Xbuild. And since we're starting from scratch, we're not editing an existing file, it comes up with sort of this blank screen. So if I go to File, New, it'll bring up this screen where I can enter my metadata about the experiment. So I'm going to call this Almaty wheat demo. You can put anything you want there. The institute, what I had called this one was CA for carrot, and AL for Almaty. The year was 2015. Oops, sorry. Actually, we enter the full.
Yeah, 4 digits.
Yeah, and then this was experiment 01. So you can see up in the top where it built the name of my file from what I've entered here. I've got one more step to do. I'm going to tell it that it's a wheat crop. Now my file name is complete. The CA for Carrick, the AL for Almaty, 15 for 2015, 01 because this is my first experiment in that location, WH because it's wheat, and X because it's an experimental file. Okay, and if I to answer your question, Jay, if I had called this 11, it would change the name up here to 11. I hope you can see that. It's pretty small.
Mm-hmm.
Okay.
Yeah, if you have full screen, you can see.
Okay. All right, so that is all that we need on this screen. There's some other information here that if you had it, you could just fill it in for documentation, but the model does not require it to run. So I'm just going to click next.
So hold on. So what is required are all the ones which has the red asterisk next to it. So those are the required inputs. So you'll see that throughout the input screens.
Okay.
Why you put Central Asia? Yes, CA means Central Asia.
Well,
yeah?
so we did this original experiment for the Carrick project. Yeah. So it was CA for Carrick, but yes, Central Asia works too.
Oh, okay.
Yeah. Okay, so when I click next, it goes to the next screen. I've already told it that we're growing wheat. And so now we need to look for a wheat cultivar. And when I click on the cultivar menu, it shows me all of the cultivars that are available for wheat, for the series wheat model. I have at least one in here that you do not have, so unfortunately, I'm not going to use that, but this is a cultivar, this North Kazakh 1 was actually calibrated for Northern Kazakhstan, but since that is not in your files, I'm not going to choose that. And I'm going to go with, I can't remember what I had before. I think I just used the default. I wasn't sure what cultivar worked in this region, so I chose this default wheat cultivar. Okay, so I'm just looking at my notes so I get it right. Okay, so I'm going to click next. And now it's asking for information about my field. And I'm just I need to identify a field name. It doesn't really matter, but it's an 8-character text string. And so I gave it the same name. It's Carrick, Almaty, and this is field number 1.
So this 00, it means year 2000. And
no, this has nothing to do with year. Right, you can think of a field as field properties as being more stable than year to
this
year.
part confused me before. Yeah, this was my original question. So I saw this 00, it means year, so it means year 2000. Experiments number 1.
Yeah, I can see why you were confused. But this, for a field name, it's considered to be more stable. It doesn't change from year to year. So you might have a multi-year experiment that is always going to use the same field information.
Okay, so last four numbers doesn't relate it to the year and numbers, just state number. Okay.
Yeah, in this case, that's true.
Okay, it's clear now. Now I just
Okay.
understand.
Okay. All right, so the weather station, so I've just added a file and Xbuild is not going to know about it. So yikes, I should have done this first. I'm going to need to refresh my screen or refresh the database. Sorry. So what that's going to throw off the whole order of the way things
I
are
think
done here.
you don't have to look for that station if you can use a station name.
Do we have to refresh also?
No, don't.
I just follow your steps here just to be sure.
Yeah, no, it's not going to find Almaty because I just added it. So you know what? I'm
You can
gonna,
save. You can save and then refresh. Just file save and then refresh.
yeah, but then I don't go. You know, I don't have this nice
Or the next
step by step.
planning. Yeah.
Yeah, you know what I'm going to do? I'm going to give it the wrong weather station, and I'm going to go back and change it later, just so we have.
So we have to choose same, yeah? Alma, Georgia.
Yeah, I'm going to go back and change this later. So this is the wrong station, but it'll get us. It'll allow me to keep going, and then I'll show you how to change that later. Okay, so now for soils. This is a potential production experiment. In other words, we're assuming there are no limitations of soil water, and there are no limitations of soil nitrogen or soil phosphorus or any other. So it doesn't matter what soil we use. When we start simulating soil water and plant uptake of water, and when we start simulating nitrogen processes, the soil matters a lot. But for now, it really does not matter. So I can choose anything I want. And I'm going to look for one of the default DSAT. In fact, the first default one I get is a deep sand. Again, it doesn't matter. You have to choose one, but in this case, it's not going to be used. Okay, so I'm going to click next. And now it wants information about planting, when the plant was put in the ground and other information about the planting. So now I'm going to refer to my notes so I get the same thing that you got. My planting date is April 1, 2015. Look at the format. This is going to use your system date format. Okay, my system is telling me 2-digit month, 2-digit day, and 4-digit year. Your system may be different, so just pay attention to that and you should be okay.
Sorry, I have a question on this part. In your case, you have 2 DD YYY 4 times, and in my in my part, it showed just 1 M and /1 D and 4 Ys.
Okay, so you would enter 4/1/2015.
Yeah, without 0, yeah?
Yeah, I think it would work with the 0, but
It probably
yeah.
works.
Yeah.
Okay.
So just, yeah, so sometimes I set my system clock, it always resets itself, but I like to use YYYY-MM-DD. That's my default, but my system clock has changed itself. And so you just have to pay attention to whatever your system is using. Okay, so I'm going to leave the emergent state blank. I'm going to let the model calculate that. The planting method, dry seed. Okay, so you can see a pull down menu of different types of planting, but typically wheat, we're going to put dry seed.
What does it mean, dry seed? We don't add anything, yeah? Just
yeah,
natural,
it's just, yep,
natural,
it's just a seed. Yep. And that's pretty typically what we'll see with the cereal crops. The planting distribution, we're going to put in rows. Plant population, we use 200, and this is plants per square meter. And we've got the same thing at emergence. We assume 100% emergence. You don't, yeah. The row spacing we set at 16 centimeters. So the rows are 16 centimeters apart. We assumed that the rows are 0 degrees from north. This affects the photosynthesis. And the planting depth was 4 centimeters. So we good to go on?
What about year? Do we have to select this 93, 94, 95? Do we have to choose one
No,
of them?
so remember I picked the wrong weather station. For the station I chose, it only has these years of weather. So it's kind of a warning that, you know, this date will not have any weather associated with it. But remember, I'm going to go back and change to my Almaty 2015 weather. So I'm ignoring that for now.
Okay, so in ideal case, it will show 2015, yeah, in this.
Yes. If
Okay.
I had been able to choose that Almaty station, you would see 1 year here, 2015, because there's
Okay.
only 1 year of weather data there. So yeah, that was my mistake, but yeah, we'll all learn from this, hopefully. Okay, so shall I go on?
Yeah, I think it's clear. I think. Sorry, on this level 1 description, do we have to add here something on the top part?
Okay, good. That's a great question. So a lot of experiments will have multiple treatments, and the treatments, so in this case, if I had a planting date experiment where I had actually an experiment in the field and I planted crops at a 2-week interval, for example, then I would have 5 different planting levels, each with a different date. And in that case, you would want to give it some name that this is, you know, April 1st, 2015. But since the basic setup, we've given it planting information, we've told it where to get the weather and soils. And now the next thing I want to do is set up these simulation options. So this it doesn't have anything to do with the experiment in the field, but it tells us how we want to simulate that information. So I'm going to click on simulation options. And again, you can give it a name, but I'm going to leave default simulation here. Okay, so this is potential production. The first thing I want to do is set the simulation start date. And in the demo I created before, I used February 19th as the start date. So I'm going to do the same thing here. So 0215. So it's starting the simulation a little bit early. This kind of spin up simulation. So we're simulating the field before we put a plant in. This becomes important if you're doing water and nitrogen simulation and you aren't 100% sure what the initial conditions were. For potential production, it's not as important, but yeah, just for consistency, I'm going to set that date a little bit before the planting date. Okay, so since this is a potential production, I want to switch off simulation of water and nitrogen. Excuse me. So I'm going to go to options. So under the options tab, it has all of these processes that can be modeled in DSAT, and it gives you the option of switching them on and off. So I'm going to switch water to no. And what that means is that water is considered to be unlimited. It's assuming that the plant can get as much water as it needs. So we're not even going to simulate those processes. Same thing for nitrogen. Nitrogen is unlimited. Symbiosis is for nitrogen fixing crops, so wheat doesn't do that anyway. All the others are set to no. We have no tillage. And then here we have CO2. This is atmospheric CO2. It gives us various options. We can use a default value of 380 volumetric parts per million. We can use the actual as measured at the Mauna Loa Observatory in Hawaii. This is that healing curve that shows the increasing CO2 over time. Or we can actually read it from the weather file. Our weather file doesn't have it. I don't want to use the 380, so I'm going to keep it at the Mauna Loa CO2. So that's actually going to read the value of CO2 in 2015 from a file. Okay, what's next? Okay, so the next thing we want to look at is the outputs that come from the model. So I clicked on the Outputs tab, and we do want to see the growth. So these details are the daily output files, and we can switch them on and off. We're not simulating water, so we don't need that. We are not simulating nitrogen, so we don't need that. No phosphorus. I'm going to leave the operations on. This gives us some options about how detailed some of our, whether we want detailed outputs. I'm going to leave it at normal. We can tell it how often we want it to output the daily output. If you are generating huge files, you can only see every 10 days, but I want to see every day. This gives us an overview file. This gives us a summary file. We're going to leave those on. This gives us the option to get comma separated, but I'm going to leave it at the ASCII text file DSAT version. Okay, so I think we're good there, and I'm going to click OK. The last thing we need to do is set up a treatment table. We have only, actually, before I do that, before I forget, I'm going to go back. I'm going to refresh. I'm going to save my file. It's actually saving it here. And I'm
So
going to
not save us, just save, yeah?
Just save, yep. And that's going to save it as the file name that was built based on the information we gave it. And in fact, it tells you exactly where it goes. It goes in on the C drive, DSAT47, wheat folder, and here's the name based on these inputs. Now I'm going to refresh the XBuild database. So what this does is it reads in all the names of the cultivars, the weather files, the soil files. It takes a little while to rebuild, but now XBuild has that database rebuilt, and that weather file that I added right before I started this is now visible. So I'm going to go back into my field section. Instead of Alma, Georgia, I'm going to pick Almaty, Kazakhstan. So now I've got it. So Jay, are you?
Yeah, I'm on same page. Yeah, very good. Yeah, thank you. I follow
And it
you.
worked?
Thank you.
Okay,
Excuse me.
awesome.
Could you please tell where should we exactly copy the file name CAL 1501 WHX?
Yes, it
I
goes
copied
to.
it. I put it in the DSAT 47. Then weather. Oh, sorry.
That's right. It goes in the DSAT47 weather directory.
Weather, right?
Yep. Yep. Here's mine. So it's DSAT47 weather. That's where it's going to look for it by default. We good? Okay, so I'm going to click OK on that. Now I want to build my treatment table. So I'm going to come up to treatments. I'm going to give this treatment a name. Let's call it Almaty potential production. And so I've given it, I only have one cultivar, I only have one field. I don't need initial conditions because it's a potential production. I gave it information about planting. I don't have any of this stuff, and I have one simulation control. So I have, it's a very simple example. One one treatment. Now, what I could do is add a cultivar. Should I do that now, Garrett?
Let's run this first and then add a cultivar.
Okay, so I'm gonna save the file. Always save the file. I'm gonna get out of XBuild. And now I'm back to the DSAT shell.
So to how to go it out from this? Just put on X, or what should I put? Okay.
Yeah, so yes, you could just use the X, or you can, I think you can actually
Exit.
go to
Yeah,
file
just
exit.
exit.
Yeah,
Yeah,
there's
okay.
there's multiple ways to do it. Okay, so back in the DSAT shell, I'm going to expand cereals and click on wheat, and this brings up all of my wheat experiments, and you can see the new one is there. I didn't show you before, but this is the one I just created, and it just appeared in my DSAT shell. If you don't see it, you can refresh the DSAT database, or you can refresh the list of experiments with this little recycle symbol here. This is a different refresh than XBuild. Okay, this is a DSAT refresh, and the one in XBuild was for the XBuild. They're completely separate applications. Okay, so I'm going to click on that. I see my one treatment, and if I did everything right, this will run. So I clicked on run up at the top of the DSAT shell. It brings up the simulation window. I click run in the simulation window, and it tells me it's complete. So now I can click on the analysis tab, and it gives me a list of all the files that it just created in that simulation. It's pretty fast. Okay, so now I'm going to, let's look at, did we show the overview last time?
I think so, but then go look at it again.
Okay, so let's view, okay, so the first thing I'm gonna do is view the overview.out file. So I click on that, I click on view, and it will bring up in the default text editor, which in my case is Notepad. It will bring up the overview.out file. So this gives an echo of some of the input data. It tells me my treatment, tells me information about the start of simulation date, the planting date, where it got my weather data, the information about the soil file. And it also tells me that we're not simulating water and we're not simulating nitrogen. The next section is the simulated crop and soil status. So this gives us dates. So this is a chronological log of the simulation through the various plant stages, how much biomass was in the field at that point in kilograms per hectare, the leaf area, leaf number, and you can see all of the stresses are zero, right? Because we told it we didn't want any stresses for water or nitrogen. So we see that those are all zero. That's good.
So we will have the stress if we add something like yes, we put for water, for everything like no, no. But
That's
if
right.
we put yes, and we will have some numbers here.
Yeah.
That's right. That's right. Because this is where if you have, say, a rain-fed system and the plant does not get enough water, you will see stresses listed here. And the same for nitrogen. If there's a nitrogen deficit, you'll see that here.
We'll go through that later on when we talk about water limited production and nitrogen limited production.
Yeah, that's coming up next. We start simple. Okay, and here you can see simulated values for various plant model products, right? So that it's got day of emergence, day of anthesis, day of maturity. We also have a column for measured data, but this is a sort of fake experiment. It didn't exist in the field. We didn't measure values in the field. And so these are all -99. In DSAT, -99 means no data or missing data. Okay, so we don't have any measured data, so there's nothing to compare against. Even some of the simulated values are minus 99. For example, nitrogen uptake, because we told the model not to simulate that. But we see that the yield, so it's called product weight here, is 8,584 kilograms per hectare of dry weight. That would be the grain produced by this crop. What else? We have canopy. So the tops weight here was 17,814 kilograms per hectare. So this is a good crop. It still depends on temperature and solar radiation in the field for that particular year. So I could run this potential production for a different year and get different values here, but there are no soil or water stresses. So it's a high yield. And then we have some environmental stress factors. Again, we see a bunch of zeros and minus 99s because it's potential production, but it does tell us something about the environment during the growing season. What the maximum temperature was, the minimum temperature average over the growing or during this germination to terminal spikelet to end of vegetation to end of ear growth, or in this case, panicle or spike, end of ear growth to beginning of grain filling, beginning of grain filling to end of grain filling. And then this is for the whole season. So some useful information there. Resource productivity, we don't really need this because we did not add, we didn't simulate water or nitrogen. And then finally at the bottom, the overall wheat yield. So if I had multiple treatments, I would see those here. Okay, any questions about that? I'm going to show, next I'm going to show the time series plots.
So all this data.
So that's the basics of creating and running a potential production file. Any questions? I can go back and add a cultivar and show you how to do that. I think we have time for that.
Yeah, we're running a little bit out of time. Go ahead and show the adding another cultivar so we can deal with the levels.
Okay, so
how to just to put exit from this file? What should I put here? Just to go back.
Oh, yeah, you can just close it out with the X at the top right-hand corner. Sorry, I went too fast over that.
Okay.
I have a question.
Okay.
Yes. What about the soil type you have selected during the previous step?
Yeah,
Was it the black soil? I mean.
So first of all, for a potential production, the soil is not important.
Okay.
And so I chose, for this experiment, I chose a default deep sand is the soil that I used.
So we know that it's not representative of Kazakhstan or Mali, but this is potential production. So we don't care about the soil processes.
Okay, so if I want to go back and edit this file now, I can do it from the DSET shell. I can right click on the file and click on edit, and it brings up XBuild again. Okay, so now everything that I loaded before is here and I can make my changes. So we talked about changing or adding a cultivar. So I'm going to go to Management, Cultivars. And now I'm going to, so before I had used the default, I'm going to add a level and choose, yeah, I'd like to choose that Northern Kazakh, but you won't have that. So instead, I'm going to choose the Maris Fundin. Okay, so now I have two cultivars, default and Maris Fundin. So, and I'm gonna add a third. I'm gonna add this Newton. So now I have three cultivars. Okay, and so does anybody want to guess what's going to do best in Kazakhstan? I have no idea.
Yeah, we don't have any ideas too.
So I'm going to click OK.
It's going to be
And
default menu.
you think? So now I'm going to go back to my treatment table and add 2 more levels. So I'm going to base my levels off this first one, and I'm going to add a new one, and then I'm going to add another new
How
one.
to
So
add
now
this one? What did you click? I didn't catch here.
So I highlighted the one I want to copy, and then I click add at the
Okay.
bottom. Okay. So now I need 3 names. The first one is default cultivar. The second one was Maris Funden, I believe. And the third one was Newton. So now I need to tell the model what is different about these 2. Okay, and the difference, the only difference that I want to have is in cultivar. So I'm going to click on the cultivar and I'm going to choose Maris Funden. And then I'm going to click on the third cultivar and I'm going to choose the Newton. So now we can see that the cultivars are different, but they use the same field, the same planting information, and the same simulation controls. So the only difference is here in the cultivar. Okay?
So we just changed this cultivar. We didn't change anything on the rest, yeah?
That's right.
Okay.
That's right.
Rest
So
same, yeah?
that's right. So we want to see what the effects of the cultivar are with holding everything else constant. Okay, so I'm going to click OK. I'm going to save my file. And then, so to answer your other question, I can exit from the file menu as well. And now I want to go back and refresh. Okay, see, I still see only one treatment here, but as soon as I refresh and click on this, all 3 of my treatments show up. Okay, so let's run this and see which cultivar wins. So I clicked on run at the top of the DSAT window. It opens the simulation window. I click run model. Tells me my simulations are complete. It was fairly fast. And let's go to, so I clicked on the analysis tab and I'm going to select plant grow.out again. And click plot. That will bring up gbuild again. I'm going to select all runs. Okay, so I've selected, I can take a shortcut here. If you have a lot of treatments, you can select them all at once. And let's look at the, let's just look at the harvest product weight first, because that's what we care about. Okay, so it looks like they are very different in timing. Okay, so they were all planted on the same date, but this Newton cultivar, the phenology is longer, the season was longer, and it gives us the highest yield.